Okay, the recording is started. So good morning everyone, every student. So today we'll discuss about sieve analysis. Okay, and how to find out a grade of soil in laboratory. So allow me to share my screen first. Okay, uh, my screen is visible, right? So in the last class we discussed about I guess yeah, we have discussed about Indian standard soil classification system. Okay, so there are mainly two types of soil that we consider: the fine grained soil and coarse grained soil, and very coarse grained soil also is there. And under fine grained soil we have two type of soil: silty soil and clay soil. Under coarse grained soil we have sand and gravel. Even gravel and sand are divided under different types, like fine sand, medium sand, and coarse sand, and fine gravel and coarse gravel. And with the higher sizes, the coarse soil become very coarse soil. Under very coarse soil, we have boulder, cobalt, and boulder size. Okay, and we also discuss about coarse grain soil, fine grain soil. Yeah, and grade of soil also we have discussed. So I think you all know about what is grade of soil. So grade of soil uh, may define generally what type of soil sizes you have in a particular sample. Okay, so there may be a it may be a well graded soil or poorly graded soil. So well-graded soil is have representation of all sizes, but poorly graded soil doesn't have that. Okay, this is just the opposite of well-graded soil. Under poorly graded soil, also we have two type of soil, that is uniformly graded or gap graded and gap graded. Okay, so yeah, this is all these things we have discussed in the last class. Yeah, this curve also we have discussed about that. This curve shown graph that is called particle size distribution curve for different soil sample. Okay, so different curve you can see. So every curve represent different grade of soil. Fine, the name of the particular type of soil is written along the graph. I think you can see, and this graph is actually known as particle size distribution graph, and this curve is known as particle size distribution curve. And along x-axis it is particle size. Okay, and its y-axis here you can see percentage finer. Okay, and this will be in percentage, and x-axis this particle size in millimeter. Okay, okay, and one more thing, yeah, in this x-axis is in logarithmic scale and y-axis is in arithmetic scale. I think you are familiar with normal graph paper that till now you have used in chemistry or physics lab, whatever. Okay, so they are all general graph paper which where x and y-axis both are in arithmetic scale. Now you can see in x-axis here in this particular graph, you can see these spaces are larger, isn't it? So this x-axis is in logarithmic scale. Okay, so that all the soil particles can come in a particular graph paper. Okay, that's why this x-axis um, is converted into log scale, and this graph paper is called semi-log graph paper. Okay, in nearby shop you can find out semi-log graph paper. Okay, it's not a general graph paper, it's a semi-log graph paper. Okay, semi, why? Because it's half log, means semi matlab kya hai? One axis is in logarithmic scale and other axis will be in arithmetic scale. That's why it's called semi logarithmic graph paper. Fine. So yeah, we also discuss about particle size distribution is done by two-way: stream analysis and sedimentation analysis. Sedimentation analysis is done for fine grained soil. We're gonna discuss today about this sedimentation analysis. Okay, so we'll discuss about stream analysis for now. So it is done for coarse grained soil. Now, what is coarse grained soil? If you go again in tabular form here above this soil is classified by sieve analysis. Okay, okay, so what is sieve analysis? Here you can see in sieve analysis we use a special apparatus, it's called sieve. Here you can see this tray type apparatus. Every apparatus it's fitted one above another. Okay, fine. So this you can see some spaces are given. Okay, it's like a green type of wire is connected all over the circle. So this space, this diagonal space of particular one square, is represents a particular size. Okay, fine. So every sieve have a particular is denoted by a particular size name. Say suppose if this suppose this particular this sieve is written as this sieve for 4.75 millimeter. Say suppose this sieve this apparatus is named as 4.75 millimeter. That means the soil particle can only pass through this sieve which have soil sizes less than 4.75 millimeter. Okay, and higher than that particle, they cannot pass through this sieve. They will retain on this tray. They cannot pass through this sieve. Only the soil sizes having smaller than 4.75 millimeter, they can pass through this sieve. Okay. Similarly, we have numbers of sieve. Okay. So we'll give you a list of sieve here, like we say. Yeah. Here you can see. We'll discuss this about this table later on, but only concentrate here in this column. So it is written here IS sieve number or sizes in millimeter. Sometimes sieves are also given as number. You can find out in textbook also. Okay, so here you can see 4.75 millimeter, 4 millimeter, 3.36 millimeter, 2.2 millimeter, 1.46, like that, up to 0.075 millimeter. Okay, X second, someone is waiting in the lobby. Let me, oh no, it's, wait. Yeah, okay. So here all are done, all different, all numbers denoted as a particular sieve apparatus. Fine. Okay, I think you have get this idea about sieve. Okay, so these all are sieve. So these sieves apparatus are used for sieve analysis, or you can say particle size distribution. Okay, so under sieve analysis also we have two type of sieve analysis: core sieve analysis and fine sieve analysis. Now, how can we define this core sieve analysis and fine sieve analysis? Now, if you go to the tabular form, in the previous one, yeah. Now you can see if you are studying about this soil, that is uh, your sand particle, that is uh, less than 4.75. If you're studying about sand only, then it will be known as fine sieve analysis. Okay, and if you are studying the soil larger than 4.75, then it will be a coarse sieve analysis. It's very simple definition. Okay, yeah. So that means core sieve analysis is done for gravel fraction, that is plus means higher than 4.75 millimeter, and fine sieve analysis is done for sand fraction, that is lesser than 4.75. Okay, but up to what? 0.075 millimeter. That means you can see sand is ranges from 4.75 to 0.75 millimeter. So if you go for fine sieve analysis, you are studying means you are studying about sand, and if you are going for coarse sieve analysis, then you will studying about gravel. Fine. Okay. So let me give you a simple procedure of civil license, how to do civil license. So here you can see a simple detailed procedure of civil license. Okay, so what you have to do, so first of all, let's see, it is written here the objective of civil license is to classify the soil and determine gradation. So already known, already given, already is discussed that we need to find out the grade of soil, whether it is well graded or poorly graded. Okay, main objective of civil license is to find out grade of soil. Now, what apparatus we need? We need a set of IS sieves are taken. Okay, a set of IS sieve means it's like this set. Every sieve, okay, having different size. Okay, and these sieves are arranged in a such a manner. These sieves are individual sieves are arranged in such a manner that the sieve these gaps are higher at top and lower at bottom. That means the sieve sizes are decreasing from top to bottom. That means if your this suppose this top sieve is suppose 4.75, okay, then this size will decrease up to 0.075 millimeter. It will set like this. Okay, even here in the table, here you can see the sieve sizes are decreasing like this, 4.75. Okay, first you have at the top we have to place, suppose we'll come from the bottom. Okay, Let's first take this 0.75 or 75 micron sieve. Okay, above this you put the larger one. That's suppose 0.15 mm sieve you have put it. Above this zero point 0.3, above this zero point 0.6, like that, like 1.2, 1.4, like this. From bottom to top, the size of the sieve will go on increasing, and at top it's come like 4.75. So since it is 4.7, we can say it is a fine sieve analysis. Okay, we are only taking only sand particle here because it is ranges from 4.75 and up to 0.75. Okay, so sieves are arranged in this manner. Fine. So just take an example. If I pour some soil, okay, from the top of the sieve, what will happen? Some soil particle will fall down to the last tray, isn't it? And some will be written here, means at every sieve some soil particle will retain on its base. Okay, why that they have written on particular sieve? Because they are larger than that respective sieve. Okay, now suppose in the particular soil sample have some soil particle sizes more than 4.75. Okay, now if I pour the soil above this first tray or the first sieve apparatus, what will happen? Most of the soil particle may fall down. Okay, but the soil particle which having sizes more than 4.75, they will not fall down. Okay, they are restricted by this small gap of this sieve apparatus. Okay, so like this, and at every, it may not like every sieve apparatus have some soil particle written on it. Okay, so let's go to the procedure. How much soil you have to take? Like say 500 gram you just take. So suitably a suitable amount of pulverized dry soil. Pulverized means make it fine. Okay, make it fine. Like by hand or manually or mechanically, you just break down the soil, make it fine soil. It's called pulverized dry soil. You have to take say 500 gram. So it's taken and sieve through different sieves with the help of sieve shaker for 10 to 15 minutes. So there is a apparatus, sieve shaker, or you can also do manually. Okay, you just take the whole set by your hand and just shake the apparatus for 10 to 15 minutes. Okay, then what will happen? Some soil will, due to the vibration of shaking, soil particle will fall down at different sieve, isn't it? After that, what you have to do, we have to take the weight of the soil retained on each sieve is determined. Okay, you have to take the weight of soil retained on each sieve. After that, percentage weight of soil retained on each sieve is determined. After that, percentage finer is determined. Okay, then after that, we have to find out finally plot the percentage finer versus size of sieve on semilog sheet, that is semilog graph paper, will give the type of gradation, effective size, coefficient uniformity, coefficient curvature. Okay, we'll discuss about these two terms coming. Okay, we're coming on that. So this is a overall very basics procedure. Okay, so I'll discuss this here. Now we need to prepare this tabular format. So this is the table for sieve analysis. So in the first column, you have to put this IS sieve number or whatever sieve you have taken for sieve analysis in a decreasing order of size from top to bottom. Fine. At the top 4.75, at bottom 0.075 millimeter. Fine. Now after sieving, what will happen? Maybe it's some sieve have retained some soil particle on it, isn't it? Then we have to take the weight of its soil written on its sieve. Okay, like suppose whatever gram in gram weight should be written here. Fine. After that, percentage on each sieve you have to find out. That means you need to find out the percentage. That means take the total weight. Okay, now for uh, out of total weight, how much weight is written on 4.75 says it will come in percentage. So we have to find out as terms of in terms of percentage. You have to find out this parameter. Okay, this value. So this very simple thing. Okay. After that, this column is represents what the percentage 3, yeah, the percentage written on this SIP. Okay, individual SIP. After that we have to find out cumulative percentage written on each SIP. That means suppose 10 gram is written here. Okay, sorry, yeah, 10 gram is how much percentage it will come in percentage, right? So say 10% of total soil is written here. Suppose say here again say 20%, 20% of total soil is written on this in on this sieve. Now, how to find out cumulative percentage retain? Now here we need to find out that this data will be similar to this top one. That means suppose here at 4.75 sieve, 10% of total soil sample have retained. So this 10% will become here also. Okay, that means up to 4.75 for total sample, 10% sample have retained on these 4.75 sieves. Now when it come to second sieve, I already told you, say example here 10, now say example it is 20. Okay, so 10% retain on 4.75, 20% retain on 4 millimeter sieve. Okay, now when it come to second, that is what do you mean by cumulative? We have to take both, that means up to this level. When it come to second level, that means up to 4 sieve size, how much percentage finer is there? That means this plus this, that means 10 plus 20, how much? 30. So it will come 30. Okay, now similarly we have to follow the same procedure. That means this 30 percentage plus whatever value is here, this plus this, it will give you this. Okay, like this plus this, it will give you this. So it's like a cumulatively you have to find out the percentage retained on each sieve. Fine. After finding percentage retain, you need to find out percentage finer, which is just the opposite of percentage retain. Okay. Now suppose it is percentage means what? Total we have considered 100. Percentage means we have taken considering that total is 100. Now out of 100 some percentage is retained. Yes, out of 100 how much percent is retained? So it's how to find out this percentage finer. Just subtract whatever value is here. Okay, subtract this value by from 100. That means 100 minus this value, you will get this percent finer. 100 minus this value, you will give you this value. Okay, 100 minus this percentage return, you will give you percentage finer for individual sieve. Okay, so this is the table you have to prepare in laboratory or in a, say after the lab test. Fine. I think it's very
Hello,
simple. You can
sir.
also follow the video link. Okay. So you will
Oh,
get very easy to understand. Anything you want to ask? Hello?
हेलो सर।
Yeah.
सर यहाँ पे अगर क्वेश्चन पुट अप हो जाएगा कि
Hmm.
largest size of the ship will be 4.75, right, sir?
If you are going for sieve analysis for fine grain soil, okay, sorry, I mean fine sieve analysis. Okay,
Okay, sir.
there's lots of
A
sieve
person will
sizes
ask,
higher than 4.75. Okay, but for timing, for example, I am showing you only 4.75 as a top at the top. Okay, you can put larger than this also.
and the smallest will be
Yeah, and the
minimum will be
smallest sieve is
7.7.
fixed. It is 4 points. Sorry, 0.075 millimeter or 75 micron. Okay, it is the smallest sieve size.
Smallest size.
Yeah.
Yes, sir. Thank you.
Okay, so you can find out if somebody asks you what is the smallest sieve size, you can answer this 75 micron sieve is the smallest sieve size. Okay, this
Okay,
is
sir.
0.075 millimeter is the smallest sieve size. Fine. Okay, so after preparing this table, what you have to do? You have to plot this graph. What kind of graph? This kind of graph. Okay, so this graph will give you what? It will give you this one. This that means particle size distribution graph that you need to prepare after the preparation of the table. Fine. So here I already told you this is a semi-log graph paper. Now you can see this axis is in a larger size. Okay, so 0.01 0.1 10. Okay, it will come like this, or you can also alter this x-axis. You can also start from 0.001, then 0.1, then 1, then 10, like this also. Okay, and its y-axis is representing your percentage finer. Percentage finer is what? That these things, the that 1 2 3 4 5 fifth column. Okay, percentage finer, whatever value you have got percentage finer with respect to different sieve size. Okay, you have to plot here. Okay, so for every sieve size it's written particle size, but actually you have to find out, we have to put sieve size. Okay, so every sieve size you will get some value. This point represents percent finer with respect to some sieve size. Okay, after plotting this point, with your hand you can join this whole point freely. Then you will get a curve. This curve is represent particle size distribution curve. Okay, so like this you need to prepare this particle size distribution curve. Now question will arise, how can you find out grade of soil from this curve? Okay, now I already told you, by just visualizing the graph, just visualizing the graph, you can find out whether the soil is well graded or poorly graded. Okay, but sometimes it is not that precise. Okay, so we also go for some mathematical or analytical um way to find out grade of soil. Okay, now for that you need to find out these three important parameter. Okay, that is what? D10, D30 and D60. Okay, D represents what? D represents size or diameter of particular soil particle. Okay, now 60 represents what? 60, 30, 10, they are representing percentage. Okay, that means, now here you can see the definition of D10. So it represents a size in millimeter such that 10% of particles are finer than that size, and it is also known as effective size. Similarly, we can also give the definition of D30, D50. You can also find out D50, D40, D60, D70, anything. Okay, but just try to understand what is D10, D30, D60. So these are they represent sizes in millimeter such that if you are giving definition for D10, then it represents size in millimeter such that 10% of the particles are finer than that size. Okay, now say example, if I say D60 in this particular graph, D60 is, how to find out D60 value? It represents size. Okay, now where you can find a value in this x-axis. Okay, but it related to your 60% finer. That means first you have to find out this 60% point. Okay, this axis represent percentage finer. Then find out this point. This it is represent 60%. Then you just come horizontally up to this graph, like this, up to this point. Okay, coming like this up to this graph, then come vertically down up to the horizontal, and it will touch one point in x-axis, and this point represents what? One particular size. Okay, now suppose this is your point 9. Okay, suppose this is 2. Since it is increasing in this direction, so say this is 2. So 1, 2, 3, 4, 5, 6, like this, it 10 up to 10 is coming like this, right? So say this arrow marks is not touching number 2. Okay, so what you can say, that 60%, since it is related to your 60%, so we can say 60% of total soil is finer than 2 mm size. Okay, now if I say 10, D10, now D10 is starting from 10 percentage. If I start from this point and come horizontally like this up to this 10 graph. Okay, then up go vertically downward up to x-axis. Now let's say it is what? 0.009. Let's say this is the point representing 0.009 millimeter. Okay, now what you can say, 10% of the total soil, 10% of total soil is finer than 0.009 millimeter. Okay, similarly we can say for 30%, say this is your say zero point 0.4 or zero point 0.5, say it is the point 0.5. Okay, so we can say 30% of the total soil is finer than 0.5. Okay, so I think it is very easy to understand. Any doubt till now? Okay, after finding
No, sir.
D60, yeah, after finding D60, D30, D10, which are actually represent size in millimeter in x-axis, you can find out in x-axis. After finding this, you can find out next parameter. This is uniformity coefficient and coefficient of curvature. Okay, now this is two new parameter which can be find out from the graph only. So what is this uniformity coefficient and coefficient of curvature? So uniformity coefficient is what? It is a measure of particle size range. Okay, particle size range. That means it represents what is the range of soil particle you have in particular soil sample. Then coefficient of curvature is represents what? It represents shape of the particle size curve. So what kind of shape you have in your particular distribution curve. Okay, so this defined by this coefficient of curvature, and it is defined by this particular formula. Okay, so coefficient of uniformity can be found out by this formula d60 by d10. Then coefficient of curvature is found out by this formula, that is d30 square by d60 multiplied by d10. Okay, now what is the use of these two parameter? It's very useful to find out grade of soil. Okay, now here you can see some important parameters given here. For well graded soil, well graded soil, if you are using suppose sand particles, then this cu, that is coefficient of uniformity, this cu must be greater than 6. The value must become greater than 6. Or if you are going for a similar for gravel, then it must be greater than 4. If this value satisfied, then you can say this is a well-graded soil. But along with this CC, coefficient of curvature, this also must be lie between 1 and 3. Then only, if these two conditions may satisfy, then only you can say the soil is well-graded soil. Okay, I'm repeating that well-graded soil, for well-graded soil, this Cu, that is coefficient of uniformity, must be greater than 4 for gravel, or must be greater than 6 for sand, and coefficient of curvature must be lie between 1 and 3. Then only we can say the soil is well graded soil. If the one of is not satisfied, then you can say this is a poorly graded soil. Simple as that. Okay, and suppose Cu become 1, then you can say this soil is uniformly graded soil. That means for uniformly graded soil, Cu become 1. Okay, so these things that you need to remember, sometime in some exam may ask. Okay, this criteria for well graded soil. Fine. So this is the way how to go for practical for doing particle size distribution to find out grade of soil by civil license. Okay, so till now anything need to ask? It's very simple to understand. Yeah, it will look like very lengthy, but it's very simple. Okay, so take your time. You just go through the video link and the manual. How just go through the notes also. If you don't, if you still have any doubt, you can ask me whether in the class or in the coming classes also. So till now I'm just stopping by sharing. Okay.